5.2 is OR rules, and remember OR means add. So most of this section is going to be review. We're going to talk about probability models, sample space, your basic rules, doing probabilities from tables. This is all review of regular stat. The new thing is something called Venn diagrams that we're going to be using. Okay, so let's take a look at the sample space and what sample space is. Remember, you're supposed to be writing these down and taking notes on this. So if you're not printing this out, I need these kind of jotted down, the definitions, and whatever I write, you should be writing on your notes. This is a homework. All right, so sample space. Let's talk about rolling 2 die. If I roll 2 die, the sample space is heads, tails, tails, heads, heads, tails, and tails, tails. There's 4 outcomes if you roll 2 die. These are the way that the 2 dice can come out. 2 heads, 2 tails, 1 head and tail on each coin. So there's 4 outcomes. That is your sample space. Make sure you write this down. So sample space is all your possible outcomes. The next thing is what a probability model is. A probability model has the outcomes listed, and you should recognize this from regular stat, and the probabilities. It's like a little chart. That's what a probability model is. Let's say this is the outcome for tails. Sorry, I don't know what's happening with that. I hit a button. Tails. Okay, and then, so if you're looking at 2 coins, you can get anywhere from 0 tails to 2 tails. Okay, if you get 0 tails, there's 1 out of 4 chances to get 0 tails. There's 2 out of 4 chances to get 1 tail, and there's 1 out of 4 chances to get 2 tails. That's a probability model. It's just what can happen and the probability below it. An event is any of those outcomes. So an event would be the probability of getting 0 tails. That would be an event. Okay, a probability would be, which would be 1 out of 4. The probability would be of getting at least, ALO I call it, at least 1 tail. At least 1 tail is 1 or 2, so the answer to that would be 3, 4. So there's your basic probabilities. Okay. Here's all of your rules of probabilities. You may want to pause and write these down in your notes if you did not print this out. So remember that the probability of any number has to be between 0 and 1. We can't have negatives, and we can't have any values over 1 or 100%. All your probabilities must add up to 1. Okay, that's how you check to make sure it's a valid probability distribution. Can't have negatives, can't have over 1, and all of them have to add up to 1. So basic probability is what you want over the total. And then a complement is 1 minus it doesn't occur. So the complement rule looks like this. So whatever the complement is, whatever you want, 1 minus it, it's just the opposite. Okay, so that's how we write complements in AP. You may want to jot these down. And then if we talk about 2 events that have no outcomes in common, or whether they do have them in common, that's the next thing we're going to talk about, is mutually exclusive and not mutually exclusive. Okay, so the word mutually exclusive sounds hard to understand, but the way that AP describes it, which is kind of better, is something called disjoint. It means that they have no outcomes in common and they can never occur together. If that is true and you're doing an OR, then OR means add. You just take the 2 probabilities and you add them together. All right, so the probability of A plus probability of B. An example in cards. If I'm talking about the probability of hearts, or I'm talking about the probability of spades. An example would be, how many hearts do I have? 13 over 52. How many spades do I have? 13 over 52. Can you have a card that is both a heart and a spade? No. So we call that mutually exclusive or disjoint. Excuse me. When doing what we call a Venn diagram, the Venn diagram is going to look like this. The circles are disjoint. You're going to have a circle for hearts, and you're going to have a circle for spades. And the two things, I don't know why this is acting up. And the two things are disjoint, and you're going to have 13 in each, and they are disjoint. Let's see if I can erase some of that. Sorry about that. Okay, it's being very touchy today. I'm not sure why. Okay, another example would be a probability of rolling a, let's see, in 2 dice, rolling an 1 or a 6. Probability of rolling a 1 is 1/6 plus, because or means plus. Rolling a 6 is 1/6. They are disjoint because I cannot roll one time and get a 1/6. Can't do it. I can't pull one card and get a heart spade. Okay, so disjoint or mutually exclusive, the circles are not joined by anything. They don't have anything in common. Okay, now we're going to talk about when they do have something in common. All right, so let's talk about it in a table form first. When finding a probability of 2 events, we use these two-way tables, and basically it's just a chart. They call them two-way tables. You have one categorical variable here and one here. They're called two-way tables. All right, so this is the probability that a student is male or female and has pierced ears or not. Okay, so the first probability is, what is the probability that they have pierced ears? Well, you find the total, which is 178. Oh, not 6, 178. And then it says, what's the probability they have pierced ears? Doesn't say anything about gender. We just want to know if they have pierced ears. Total pierced ears, 103. Okay, now the next one we want to know is a male with pierced ears. Your total is always, the denominator is always the total of your chart unless you're doing those given problems, which we'll talk about in the next video. So unless it's a given, then your total, the denominator is always the total of everything you have. Okay, now we want a male and they have pierced ears. So, and where are my males that have pierced ears? Right here. Male and pierced ears. That answer is a 19 over 178. And I'm not going to worry about simplifying right now. Okay, next one. Let me erase my chart because I wrote all over in here. Okay, the next one I want is a male or has pierced ears. So my males are 90 or they have pierced ears, 103. So it's going to be 90 over 178 plus, I have no idea what's wrong with my tablet today, sorry. Pierced ears is 103 over 78, 178. And then if we look at it, we counted these two twice. So we counted them both in the males and we counted both in the pierced ears. So we got to do minus 19 over 178. We have to subtract out the both. Okay, because we counted those people twice. This is called not mutually exclusive. When you do your circle, if there is an overlap, they're not mutually exclusive. And you ask yourself, is there something they share? Yeah, there's 19 people. Let me clear that up. There's 19 people here that were both shaded blue and shaded yellow to make that 19. So there's 19 people that are overlap in both. So if you're thinking about like in a room, and I have 178 people in a room, and I say all the males stand, 90 stand. And then I say to you, okay, everybody that has pierced ears stand, 103 people stand. How many people stood up twice? Well, that's the 19. So you counted them twice. So you counted the 90 with the males, and you also counted them again with the pierced ears. So you have to subtract it out once. So that's how you do it with a two-way table. Basically, circle what you want. If anything's circled more than once, you've counted them twice and you have to subtract it out. Okay, so that's the two-way table way of doing it. And we're going to come back to the Venn diagram way in a second. Okay, so let's talk about these Venn diagrams. If you don't have things that are disjoint, okay, so here's what disjoint or mutually exclusive looks like. So mutually exclusive looks like this. You have two separate circles, an A circle and a B circle. They're disjoint, they're not joined. Okay, this is, when we're talking about two things that have in common, this is your overlap, okay, of the two things that you have in common. If I want both of those things, we call that an intersection of the two. They have to be both in here and in here. That's intersection. How do I remember intersection? Intersection is an and. They are both in A and B. So when I put my pen down, they're in both. So intersection looks like an A and an and. All right. Union means or. Okay, so union means or. Okay, so what does that mean? That means it could be in A or B or both. So it could be in A or B or both. So when you're talking about a union, you would just add everybody up. This plus both. All right, so that's the meanings of the Venn diagrams. So if we're talking about something that's not mutually exclusive, it's going to look like this because they share two outcomes in common. Here's an example. Let's say you're talking about cards again, and you're talking about probability of 7 or hearts. Okay, you're talking about a 7 or hearts. So let's say, let me clean this up. Okay, so let me change this to black for a minute. Okay, let's say A is the 7s. Okay, so this is the 7s, these are the hearts. Okay, 7, I have 4 7s and I have 13 hearts. When you're doing a Venn diagram, you should do what they share in common. So what is the intersection of these two? How many cards are in both circles? Basically, how many cards are 7 and a heart at the same time? That would be the 7 of hearts. You have one card that is a 7 and a heart. You do that first. Now, how many 7s do you have in a deck of cards? Well, you have 4 total in this circle. Total. 4 total. So you have 1 7, so that makes 3 just others. So if I total this up, I have 4 7s. 3 and then 1 that is both a 7 and a heart. So you do that first. Now let's look at the hearts. Okay, the hearts are 13 hearts total. We already have 1 here, so this would be 12. So if I'm doing this with a Venn diagram, 7 or hearts would be the union of these. It would be the union. So I would do 3 plus 1 plus 12. That gives me 16 out of 52. Now, if I'm doing it without the Venn diagram and I'm doing it just the mathematics way using the OR function, I would say, how many 7s do I have? 4 plus, because it's an OR, hearts, 13, minus, and then you have to think to yourself, how many overlaps do I have? How many did I count twice? Well, I counted that 1 twice. Either way, you get 16 out of 52. If you show it visually, you're subtracting it out as you're doing it. If you don't show it visually and you're showing it as the formula, then you're going to have to subtract your double out in the end. Okay, so let's go back to the pierced ears one and look at it as a Venn diagram. Okay, so I'm going to make a Venn diagram, and I'm going to have male, and I'm going to, A is male and B has pierced ears, and then P for pierced ears. Okay, so I'm going to look at this table and see how many I have that are both male and also pierced ears. Do you see that right there? That's that 19. That is going to go here. That's your overlap of 19. That's going to go there. All right, now male total is 90. 90 minus 19 is the 71. Do you see it there? Here, total pierced ears is 103. 103 minus the 19 I already have in there is 84. So if you're going to do it with the Venn diagram, as you do the problem inside of the Venn diagram, you're already subtracting out your doubles. So this way, it would just be 71 plus 19 plus the 84 over 178, and that would be your total. So you're already just kind of just adding these up here. All right, so two ways to do it, with the Venn diagram or with just the mathematics function. Okay, so let's take a look at this. Of 400 college students, 120 are enrolled in math, 220 are enrolled in English, and 55 are in both. All right, so if the probability that they're enrolled in mathematics, so total mathematics is, just look at the problem, mathematics total 120 over 400, and I'm not simplifying anything. You can always simplify on your own. I'm going to leave them because this way you can see where they're coming from. And on the AP exam, you don't have to simplify either. Okay, math or English. Okay, so let's do it this way. Math or English. Probability of math, 120. Probability of English, 220. Now, you've counted 55 people, right? There's your or, so you add, but you always have to think, did I count anybody twice? Do I have to subtract out? Minus 55, and then you would put that over the 400. All right, so let's go down here and set up a Venn diagram for it and show you the Venn diagram way. So we have math, and we have English, and I'm going to change my color. So I do my overlap first, so that's 55. Okay, now math, total math are 120. So I've got to subtract that out. So 120 minus 55. So I have 65 people here because my whole circle has to add up to 120, and I already have 50. I don't know why that's doing that. Keeps changing on me. 55. Okay, now let's do our English. English, we have 220 minus 55. We get 165, so that's 165. Okay, the student is enrolled in math or English, but not both. So the question is, I want math or English, but not both. Generally, when you do an or, it's always one or the other or both. But if it says it, that means you don't want this piece here. So you're going to have to take this part out. So the answer to this is just 65 plus 165 over 400. Okay, there's an example using the Venn diagram, but not both. Alrighty. In a group of 35 children, and don't worry about the numbers, I forgot to delete the numbering on these, so just ignore that part. I just put some examples up. And that is somebody's alarm going off in my house. It's early in the morning. Sorry. Anyway, a group of 35 children, 10 have blonde hair, 14 have brown eyes, and 4 have both blonde hair and brown eyes. If a child is selected at random, they have fine blonde hair or brown eyes. So let's do it both ways. So blonde or brown. So we have 35 children. 10 have blonde hair plus or brown. 14 have brown eyes. Minus both. 4. Okay, so there's the math way to do it. So you would get 28 minus 4. 24 minus 4 is 20 over 35. Okay, now let's do it as a Venn diagram. And you have to know how to do both ways. Hopefully you are copying down what I am doing for your note grade. Okay, so we got to do the overlap first. So we do the overlap first. So that 4 goes there. Now, how many blondes do we have? We have 10. So that leaves me with 10 minus 4 is 6. Browns, how many browns do we have? 14. 14 minus 4 is 10. And you see if you add these up where you get the 20. So just 2 different methods of doing the same problem. Okay, so pause the video and try this next one. Write it down on your paper because you're going to upload these notes. Take a minute to do this and then resume. All right, so here we go. I'm going to do the Venn diagram way first. I like Venn diagrams. Okay, we have Acme College, not college, corporation. And we have Mills. I was thinking of college. Both is 15. I'm not even going to put the decimal in. So Acme is 35 minus 15 is 20. 48 minus 15 is 33. I know it takes a lot of patience to look at my nasty writing. And then I want receiving an offer of Acme or Mills, but not both. So that means I don't want this middle part here. So I want 0.2 plus 0.33. So the answer is 0.53. Now, if you're doing this without the Venn diagram, here's what you have to do. You're going to do 35 for Acme plus 48 for Mills minus 2 15s. Here's why. You're going to have to subtract 15% once because you counted these twice. Then you're going to have to subtract the 15 again because you don't want them counted at all. You only want one or the other. So in these types of questions, I think it's easier to sometimes do the Venn diagrams. All right, last one. Last page, sorry. One card is drawn from a deck. What is the probability of an ace or a red? On this one, I'm just going to do the word. So I want a probability of ace or red. All right, so how many aces do I have in a deck? 4. You better learn the deck of cards if you do not know it. Plus, because it's an or, red cards is half the deck, which is 26. And then you think to yourself, do I have any red aces? Well, you have 4 aces, 2 are red and 2 are black, so I have to subtract that out. Which then gives me 28 out of 52, and I'm not going to worry about simplifying. All right, last problem, a 2-way table one. Okay, what is the probability? We have males and females, and we have genes and others. What is the probability that a person is male and wears jeans? Okay, male and means they have to be both. So male and jeans, 12 out of the total of 36. Find the probability that a person is female or a male. So females and males, we just circle them. There's no overlap. They're mutually exclusive. So it's 100%. So it's 36 over 36. Next one. Find the probability that a person is female or wears jeans. Okay, find the probability that a person is female or wears jeans. So females, 19, wears jeans, 20. So it's going to be 19 over 36 plus 20 over 36. Sorry. minus, what did I do both? Minus, do you see that 8? I did both over 36. So if you look at a highlighter, let me do the highlighter. So females, males, do you see where that circle twice? I got to subtract that out. Okay, and then you just simplify. So that would be 11, 21, 31 out of 36. And the last one, we'll do the males. And you should be copying these down, remember? Find the probability that a person is male or wears jeans. So male, male, 17, or wears jeans, 20. So 17 plus 20 minus the double circle, 12. And so we get what? 37, 17 minus 12 is 5. So, happened again. 20, last one, sorry. So 37 minus 25 out of 36. Like I said, I'm not going to worry about simplifying here. I don't know why my pen is acting up today. It was fine yesterday. Anyway, okay, so there we go. That's it. And that is 5.2. When you're done taking these notes, make sure you upload them to Schoology.